Well, yeah. Standard procedure, especially when I don't know well who the sub was. Like Mr. Mandrink was here last year. Ms. Price is here all the time. So yesterday I did not know as well. How things go? Any issues from the lesson? Any questions that remain?
He was good. He was sorry, but like we were really confused about parts, and then we would just ask him if he'd be helpful, and he wouldn't like just give us a direct answer. He'd show us how to get there. So
he has a math and engineering background.
Yeah, so like if you needed help, he would help you.
Yeah, he's very knowledgeable. That doesn't always mean that they can teach well, so that's why I want to check. And certain students you can get through with, certain you can't. Jenny.
Well, okay, so like he was pretty good because me, Gunner, and Owen, we finished the whole lesson, and I feel like it's mostly because like he just sort of let us work and didn't really talk that much, and we just sort of like got through it on our own.
Yeah, he wrote a positive note back to us. I like to let you guys know what the feedback is reported. There were no issues reported. He wrote a positive note. I'm coming back to you. What else was it? Crap. I had one other thing.
We had like 15 minutes after we finished our stuff to work on homework.
Yeah, I think it's also because that was also like a shorter lesson than usual. I think.
Yeah, it kind of was. The other thing I was going to mention is he did leave negative notes about the other classes. So, well, not like all, but he was honest. So, if you guys had like been goofballs, he would let me know. So, more than what is to be expected.
Yeah, I mean, you got yourself.
Like, it's like,
I don't think there's any problem about having fun and make fun.
Alright, so, if yesterday was decent, then who can pick me up with where we are, what you talked about, and what we're going to be doing today? So, obviously, today is 312. We're talking about tree diagrams, so if you want to label your notes, please go ahead and do that. Ava, sorry, you had something, Ryan, about yesterday?
Did we get any papers?
No, there were no handouts.
Okay.
Yeah. Just the homework set.
I wasn't here yesterday.
Neither was I. Hope your day was enjoyable.
Alright.
Oh, yeah.
We talked about percentages and we talked about the probability and like we did the diagrams where it's like so half of the population has blank and blank blank and the other half has blank 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 and we like multiply the fractions to find like the probabilities of someone having both or neither or
like the blood line.
Okay, so now and that was some real data. So I'm kind of sad that I wasn't here to teach that, and that it's not recorded or anything else. But I think that was a good lesson. That was some real data. So when you think about looking at the population, and looking at the world, especially when you look at like disease, it's now like 1 in 13 kids will get such and such. 1 in 10 will get of kids born today. So when you look at like what field do you want to go into, some people really take it on as like, let's identify what is a need, what like needs human attention, and probability can help us with that. So another way to represent probability and talk about it and kind of visualize it is using a tree diagram. So today is going to be all about tree diagrams. So let's say we have a spinner game where we spin one spinner and spin the other, and if we get done with the lesson quickly, you can grab Chromebooks and play with the e-tool, but we don't need to, so I figured we could just kind of go past that and come back if we decide to. So you spin the two spinners with the probabilities listed at the right. First letter comes from spinner 1, second from spinner 2. You can read that, obviously. So, let's just say, okay, let's go through these problems then, because I think we can discuss these probably together. Well, nah. Yeah, let's have you take 4 to 5. Let's see, because then we can just wham, bang, boom process through these. So if you get done with 12, move on to 13, but think about what it means to have independent outcomes compared to dependent. Make sure you bring that vocabulary back up. Our probability area model, the rectangles that we looked at yesterday. And then fair. I always love the question, is this game fair? So if you get done with that, move on to 13. I'll prove you the questions. Sounds like there's some hot there. Wild animals.
Cameron is
How long did that you tell us? No, take a private orchestra. CSYO.
Guys, on task. On task conversation, please.
when's their test?
We're going to talk about that today. It's up to you guys, but we just have to have that conversation. I'm going to give them like 20 seconds. Sometimes their peers.
Yeah, remember that happened.
Sometimes you guys were like out of hand.
Yeah. I feel like sometimes even the parents will have people like people learn about it especially during the session sometimes. Hey, you ready, Daddy?
Oh no. Go, Mr. Hudson.
Do your work.
How many all of you?
Ladies and gentlemen! If I ask any of you what you're supposed to be doing, you'll be able to tell me what you're supposed to be doing. I just kind of doubt that would match what you are doing. So can you please get on task so I can go back to school? Thank you kindly. You are all wonderful.
What did you say you were wonderful?
You gotta end on a positive note.
You have to know
I hate all of you.
Where's your tie?
It's too hot, man. Wait for it. It's not 80 degrees in October. Give me a break.
Really?
Where's your tie?
I don't wear ties. They have ties.
Maybe you can ask me what my tie is,
I
man.
don't wear a sweatshirt all day and long sleeves.
That doesn't
Take
mean you
it
wear a
off.
tie.
He wears
If you want to ask me what my tie is, you better be wearing a tie.
Okay.
So, what?
No, I looked at what I had cleaned this morning. It was all going to be too hot for this morning.
Oh, this is a probability area marker. So we'll call the bridge.
No, the probability area marker, that's one.
It's the rectangle.
So we'll call the grid.
So that's actually why I started putting these up here.
Yeah.
You should have Mr. Allen come in here and yell at them. He is scary when he yells. He's like,
I'm nervous.
he scared me last year. I was like, I don't want to hear
So, how do I make a probability area model?
it. No, wait, stop.
Okay.
Stop what?
Green light? Jenny?
Okay, basically you want to make a table with like grids, and you have to write like the percentages along each side, and you multiply like each grid by the dimensions.
I'm close.
By the percentages.
Sweet.
To figure
So-
out what has the better percentage of.
Wait, you keep saying percent. Now all I see up here is like 1 degree measure.
Oh yeah, well then in degrees. I don't know
What?
it is.
What?
And you need to be specific. Even I'm
Well,
confused.
actually,
I know what you're trying to say, you just haven't communicated it.
so that's 100%, right?
Right.
Okay, so how do I word this? Okay, so the I is 1/2, so that's 50%.
Okay, I'll agree with that.
60 is another, well, the other half, U and A, is another 50%. The
Right.
60% out of 180, that's a third, so that's about 33.3-ish percent.
half of that.
What?
Half of that. It's a third of a half. So this isn't 33%. This is actually really how much of the circle.
That's like, yeah, around that much.
What fraction?
1/6.
1/6. 1/6 is that really sweet fraction that becomes 0.16 repeating. So it's approximately 17%. So if we want to be rough, 17%. Which leaves A as its complementary percent value. We're trying to make 50, so this has to be.
33.
So that one is your 33%. And we rounded those values. And then based off the right angle, we have. Yeah, so 25% and 75%. So, please make sure you have the probability area model. Depending on which way you want to run your axes, I would put the more options across the top, but that's just me. Because. So, I would have I, A, and U. Now, if you want to do this accurately, try to make them the size that will represent their percentage. So, if we know our whole rectangle is going to be this wide, I can make my I approximately half of it. If you want to be appropriate for area model, yes. If you want to be appropriate for area model, then yes, because the area is supposed to help represent what its percent value is.
But I don't want to redo my whole chart, which is what I'm doing right now.
Well, maybe when you yelled at me to stop, I could have kept going. So, here's the deal. This was in yesterday's lesson, right? Drawing it appropriate to the scale. Did we breeze over it because we didn't want to put that effort into it?
No, I just forgot.
So okay, I get that for you. But if we look at 3-on-1,
I'm used to just dividing it up into thirds and halves.
these are equal because halves halves. This is not, right? We created appropriately sized area models. Now this is not an area model. This is just a generic rectangle model. So it talks about how the one above is useful, but this, because it's broken up in 27, would be pretty small, a little hard to show. Again, not an area model, technically. It says make a probability area model. This is not technically right. So if we're able to, now you don't have to, I'm not going to tell you that you have to every time, but if you're able to, make it look according to how it should. So then my next likely would be A, and then U.
Yeah, that's exactly what I did.
Then,
So if I added the percentages up top,
yeah, that would be, and I would almost just use the fractions. Because we're going to have to multiply them. Multiplying fractions is easier. So don't erase your percentages. But I would almost just say, if you talk about half, and then because to be 100% accurate, this is a third.
Well, I'm going to erase it. So.
And this is a sixth.
It's easier to multiply, I just realized.
And then my 25% for, what is that even, T? And then E. Because then a fourth times a half is what? Fourth times half, 8. And that's easy to solve. Fourth times third, 12th. Fourth times sixth, a 24th. So if this was completely appropriately drawn, that would be a 24th of the area of the rectangle. If it was completely appropriately drawn. Half times 3/4,
So for the A up top, is it
That's a third. Sorry, it's really.
1/3?
I need to orient my smartboard. You've gotten so much sass since you started.
See?
Kidding.
No, Jenny, you've been sassy. You started getting sassy over the summer course. You were all sassy to me, Ava.
1/3,
You did
3/4,
nothing wrong.
3/12, a 6 and 3/4.
Okay, no way.
Sure.
That's sassy.
All right. So, when it asks, is this game fair? If the letters can form a 2-letter English word, you win.
It's not fair.
So there's it, right? What other 2-letter words are there?
There's it,
It's
at, it's at, and that's it. That's the actual, those are like the
It at if.
If.
Oh, no, that's an E.
That's an E.
Oh,
No, that's an F, that's an F.
It's an
That's
F.
an F.
Yeah.
Somebody said E. You liars.
It's it.
No, it's it.
It
Equals
at.
I.
It at. It at if.
So,
It at it.
It at it.
It at.
I do not advise watching the movie. So
What?
it,
I'm gonna watch it.
it, if, at, and did you say that was it?
Yeah.
So, what are those probabilities? What are those probabilities combined?
It is.
About 53.6%.
Over 50%, right?
58.3.
Because here
Yes.
is 50%. So wait, it's not fair, but who does it advantage? You.
The student. So it's better.
Yeah, it's a student advantage. So
But it's not.
if we put it played, spun, whatever, if we did this 100 times, obviously we'd have to do both. How many times do you think you'd win?
About 58.
About 50. If your percentage is 58, then about
54.
58.
How does that?
This is 4 eighths, so you really get an eighth plus a 12th. Remember, a 12th is about 0.0825, and that would make 58%. I believe it should be 58.
Okay.
58.3.
Yeah, 58.
Okay, my decimal's a little off. I rounded.
Yeah, be careful. Careful with the roundings. That's why we did fractions down here instead of decimals. These are slightly off. So I would use fractions when possible. Moving on, work on 13, please. Now we're going to work on tree diagrams. Now, those of you that didn't want to draw it appropriately sized, you're welcome. Here is where you don't have to. The trick comes in with accuracy as the different steps add pieces in. Please don't just say you don't want to do it. So, please follow the steps, work on 13.
Whoa, that's a lot of okay.
Alright, well, do you want me to like give you this Cliff Notes version?
I've never. What is it?
Cliff. A tree diagram? So, let's say you come to school and we have like some crazy day planned. So right? You arrive, there's no like options for you. It's just you. Then we say, all right, pick a color. You might be red or might be blue. So you've now split into one of these groups. Then when those groups split, we say, all right, pick a number. You might be a 1, a 2, or a 3.
It's just splitting more and more and more.
So then you might end up a 1, a 2, or a 3.
Just like in Shift when we did like the jelly sandwiches and the yeah.
Batman, Robin.
Batman, Robin.
Batman, Robin.
So then,
Hot Wheels, Matchbox.
then we say, all right, pick one of these cards. It's going to be an up or a down. So let's say you got a blue and a 3, and then you want to calculate, well, what was my probability to actually end up on the blue 3 up team? And if these are all equal, we could figure that out really easy. But that is how we use tree diagrams, either going down or going sideways, to represent when there's options, when there's choices or a variety of outcomes, and then another choice beyond that, and another choice beyond that. And we can do it forever.
I actually figured out the probability of getting
Okay, what do you think? What's first level?
Well, first level. Wait, never mind. I just calculated.
So let's do it. Yeah, first level's half. Then the three, a third of a half, a six.
And then half of the six.
So 12. Yeah, so you have 8. So at that point, there would have been 12 splits, 12 groups. Yeah, there you go. It's pretty easy.
You have 1/3 divided by 1/2.
Wait, what was the fraction for 1/6? Yeah. Oh, 1/6. So 1/3 is equal to 8. What's the fraction for so if you were 18 to get to 1. Oh, never mind, I was looking at that.
So what's that fraction?
Right?
We're all kind of spread out here, but we need to work together.
That's the function of the question.
Explain.
Fat rats are sweet. They're smart. Shouldn't we? Not if the group isn't. If Chris has to ask a question like that, then you should not be. Working alone, Mr. Dale.
Well, everyone else in my group is working alone.
He could have.
Do that with each other. You're upset that they're working alone.
So,
Alright, should we pull it back together real quick?
sure.
Sure, okay.
Good. We have it either. We're working together. Okay, well,
Oh yeah, I looked at this. Yeah, I looked at this question. Ryan, your job in this question.
Hey, do your work. Let him do his work. Now here's one dangerous thing about tree diagrams. There's 3 letters here, right? 6 letters. So these are all like a 1/6 chance, and these are all just like a 1/3 chance, right?
It's what it looks like.
But
Yeah,
there isn't
looks
because
like.
there's only it's trying to spell proper words. Like it was just
But still, is this 1/3?
no.
Think back up to the probabilities that we had. If we're basing this tree diagram off our spinner game,
Stop.
you can't just call them a third because there's 3 options. 3 options does not necessarily mean equal outcomes. There, over on the chalkboard, we were saying randomly drawn equal outcomes. This is not. So when we label our tree diagram, which we should be drawing in our notes, what's the probability of I?
1
An 8.
No, I is not an 8. I is a half. I is 50%.
Sorry, I was just very confused. I was like, is that my 6 just really bad? Like, A? Hold on. Question? 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 Yeah.
These are kind of fun. I just want to clarify how we're going to have.
I should really just use both screens. It's a half because we were told it's a half. We didn't like do anything. We didn't figure anything out. It's honestly a half because we got told it is. So right here, I is shown to be a half. which then we had figured out U probability is
17% or 6.
a 6 is better, right, than the 17%. And the A was 1/3, right? We should already have written down for our rectangle. But I really don't want to start doing like daily notes checks and things like that.
I did it. It's just very hard to read.
I mean, I see most of you guys writing down like at least a minimal effort notes page. But I would like more than minimal. Now, TF. There's two options, right? They're half probabilities.
Yeah. T is 1/4. F is 3/4.
So not half probabilities, even though there's two, it's 1/4, 3/4. So 1/4, 3/4, 1/4. So you might want to leave yourself some space when you do these.
Yeah.
It gets a little crowded.
Mine is very crowded.
Then if we multiply down through.
This is fun.
So what is the probability of at? Getting the A, then getting the T. 3/12? 1/4 of 1/3, which is then 1/12. So, as we work our way down through here, half of a fourth, multiply straight through, it's an eighth. Half of 3/4, 3/8. So wait. What similarity do we notice with the results that we're getting for the end probabilities of our tree diagram?
Oh, the probabilities are all the same.
Remember at?
Because I know.
Yay, Ava.
Ava?
Well, first of all, I was just gonna say the same, but then also, when you look at it, the top, so like when it goes to T, it's always 1 over the denominator, but then F is always 3 over the denominator.
Yeah, because we have other ones in the first column. Yeah. We're going to get the exact same probabilities as we do in our area model. That's what we should see here. Or whether you get the multiplication results from the area model or the tree diagram, it's the same thing.
I like this method better.
I don't know which one I want.
Okay.
They're both kind of weird.
A lot more fun.
When might the rectangle be better versus the tree diagram?
The rectangle might be better when you're using decimals.
Yeah, okay. Maybe.
More exact values.
Okay, I mean, we could put decimals on the lines.
But
We could be as precise as we want to.
if you're like doing like a pass or something, like if you're doing like a race and you want to map the probability of each passer.
Okay. So if I try to rectangle diagram our Phoenix situation, right? You walked in and they said, all right, choose red or blue.
Oh, when you have more than.
Then they said choose 1, 2, or 3. And then they said choose.
Up or down.
Where do I put that?
So, once you have.
Then we'd have to have a volume probability model.
Is that
'Cause it-
actually the thing where people just have volume probability?
You could build it. Think about Legos. If you do a 1 by a 2 or a 1 by a 1 or a 2 by a 4 or the different size, you could build a probability volume model based off one choice, second choice, third choice. So, no. So this is not a moan groan situation. This, you should be thanking me.
For not having us make it through.
No, well, this is the result. This is what we do then. If you have more than 2 choices, really, that's when tree diagrams come in.
Yeah.
So we can tree diagram a I know, whatever. They're just doing their thing. I can tree diagram a 2-choice situation But I can also area model it. I cannot area model more than 2 choices. Okay, that's where a tree diagram is really important. Try 14. Here's where Ryan has a rat.
Wait, doesn't understand
It understands this question.
Okay.
It's able to now.
Okay.
That's why it's.
But can't answer it.
No, it can answer it. It already did answer it.
Did you guys at least guys the point that I was really making? Why tree diagrams are necessary?
if there's
More than 2.
Yeah.
Area models only work up to 12.
I'm paying attention.
Model.
Just do a 3D area model.
Well, yeah, but then what about 4 choices?
You can have two.
Then,
40.
um,
40.
then you're kind of
You're 40.
what?
Middle one was the.
What?
Middle one is just
I know.
a
I
one.
And
What?
then the third one is 1, 2,
Fourth
3.
dimension is not smell.
I was wrong.
The fourth
It's
dimension
on
is
The fourth dimension.
Yeah,
is
like
A 4-dimensional shape is so weird.
Yeah, exists in time.
But, like, without counting like time and stuff, like length, width, height.
There's not like a.
Well, we have the shadow of it.
Shadow.
We have the shadow of a
But then
4-dimensional object.
Okay, have you guys already
Nothing else.
processed 14 together?
What?
Have you talked about 14 together?
Not yet.
Okay, have a group conversation or something.
So what strategy did you get? We all know that.
I just did a tree. I did a tree diagram. I just didn't write it.
Always hungry.
You have to right.
No, I don't. No, I don't.
So Romeo can't smell the cheese.
There's Romeo's blind. He's right in front of me. Just go straight.
My sister's complete works of Shakespeare.
Oh.
He's not even working. He wanted me to read my
Why can't you see it? It's right in front of you.
Right there.
You broke like 2 days ago.
Put in the maze later. Right in front of me.
Yes.
All right, I have a question. Just to make sure that we're thinking about the right things. What's the probability of getting on this path?
Which one?
1/3.
Let's
1/6.
Oh wait, no wait.
you go down. There's
I didn't know what path you were
Yeah,
talking about.
1/6. Because there's
So when I think about, like, if I just showed you this really quickly, I said, which has a greater probability, A or B? The brain will B's bigger.
but it's
No.
They're both-
So
Oh no.
hold on, let me have you ponder one more question before you get back into the math. Can I choose that path and get to A?
Yes.
Yes.
Can I choose that path and get to A?
Yes.
You can't go straight that way.
Can I choose this path and get to B?
No.
Well, you can.
Oh,
You're
you
gonna
mean
jump
okay.
around.
So you did something about the other
If
one.
you turn around, you can't.
Like,
Yeah, but it's a
Oh my god.
We're
that's so
assuming
basic.
forward, like,
Okay.
Turn around.
No.
Yeah.
Wait,
You can only go forward. There's no cheese in here.
like, well, we're
You
assuming
can only
progress
go forward.
left
Chris.
or
I
right.
wonder.
It's like a machine.
And
You
then
can
you
only
get
go
stuck.
forward.
Mr. Cheese.
Right.
So, here's the thing. To calculate the probability of A, this is what I'm trying to get you guys to. How are we going to do it? What do you mean a half? Why a half? Why? How?
Like if you, there's 3 paths that go to A and 3 paths that go to B, so it's 6 paths in total.
No, it's not. That's only
1, 2, 3. 1, 2, 3. So is he right that because it's
No.
3 out of the 3 or 3 out of 6
Because not
paths?
all of them have, because not all of them have, like, you know how there are like 3 main paths, like the big ones?
Like the
Before
beginning.
they start, yeah, before they
Before they
start
start.
branching out, you, like, the middle one has like a direct chance going to A.
So think
The
about
others
the
you
out,
can just take another.
right? When we think about the in, we also have to think about the out. We have 3 chances in. This is our out right here. This is our out right there, and this is our out right here. Here, no choice. 1 out. Here, 2 outs. Here, 3 outs. Keep talking as a group.
That was
Good job.
The probability of getting through A and
61% for A.
I got 7 each.
probability.
That's 1/3.
66. Or about
So each
67.
thing would be 1/3, 1/3,
Then
1/3.
I probably did something wrong.
I got.
Why do you need yourself down?
Wait, why did I see what you're doing?
Well, probably because I have a guess that I'm probably wrong.
Why?
And then you just do.
I have a guess. I'm not sure, honestly.
What if I tell you you're right?
I got 60.
Then I'll say I'm
I got
probably right.
61.1.
You're right.
61.
Hmm?
Yeah,
Oh,
that's what I got.
I got
Oh, you said-
61.
Oh, okay, never mind. Then I'm right.
For what?
I got 61.
Have confidence in yourself, Mr. Dale.
Pass.
So,
Going straight.
You're not
All right, I'm gonna write these like on the right. Probability up the main path, up the top path is what?
1/3.
1/3. Then the probability to get to the uppermost door, 1/9, because it's 1/3 of the 3rd. So we have 1/9. Oh, that's rating super fast.
That's just like Mr. Hall's right now.
1/9 here.
oh, that's also one.
Yeah.
Also 1/9. And not color, or not thickness, color. Here, and well, actually, let's just finish out B. This entrance to B, 1/6, because it's half of 1/3.
Yeah.
All right, this entrance to A, 6, like we just saw.
That
This entrance to A, this entrance to A. So to find the probability of getting into A, what do? We add. When we add these probabilities up and convert it to a percent, we get 61%. So we only have like 3 minutes left. We are not going to get to a lot of these, so I want to try one more. Skip on down to 15 and look at those ways into ABC and try to calculate the probabilities of the outdoors. Where, what is going on? I think it dropped, it like moved the... We're not going to go straight with their questions because we don't have time. You can obviously ponder them, answer them.
Oh, we have to do another one of these.
Whoa, you get to.
I like math.
Adjust
I
your
am
attitude.
blessed too. I'm sorry. Because it's fun. You get to draw.
All right, I'm going to write real small to try to get it in the openings. Let's go purple. What's my probability going up? 1/2. Then, probability of going up from there. 1/3. But the probability of coming out this door. 1/6. Right? These are 3 options off of, they're each 1/3. So then they're each 1/6. Okay. Now we're going to go down. Also 1/2.
Why is it 1/4?
These? But like, so here the choice This is what's dangerous about writing either on the path or at the end. If I'm writing on the path and we wrote thirds up here, that was that choice at that door saying there's like this has to sum to 1, right? We made that sum to 1. So this would have to sum to 1 up, and I don't like how close this is because it's very hard to show. Up this way is one of 2 choices. Then I have to be on this path, and now I have another one of 2 choices. But now the probability of coming out, we haven't used blue here. What about here?
That is yes.
Because it's like a fourth and then it's an eighth. The same thing.
Okay, so an 8th here
And then a 4.
and a 4th here.
Okay. Pretty cool. I like the color.
What should we see, and then I'll get you guys out of here. What should we see when we look at all these fractions?
You should put it in C.
C?
No, A.
A.
You can't put it in A.
No. Okay, I'm not asking you which is better, which is worse. What should I see when I look at those like outdoor fractions, like the outcomes? I either end up in A there, B there, C there, C there.
Shouldn't they add up to 1?
They should add up to 1. If we've done our work properly, once we get some common denominators, those would sum to 1 because that's every option laid out. Has to be 100%.
In C are those common denominators.
No, this is 1/8.
Okay.
Sorry, because this had a kink. It's just hard.
Put the cheese
Right.
in C.
Wait, why not A?
C is, you can't put it in A.
All right, with that, we're a little bit over time, so you guys can quickly pack up and head out to your next class. Thank you very much. Appreciate your time. Hope you saw the practicality of probability trees. Your homework is 17 to 21. Please let me know if you have any questions. Oh, so really quick while you're packing up, when you want to take your team test and when you want to take your individual test, if I had my choice for what I think is easiest for you, I'd take team test tomorrow, day of learning Thursday, and then individual test on Friday.
Yeah. Anything
Work?
no work on Friday.
Right, exactly.
Yes.
Sweet. That's the plan.
We should do at least one test on Friday.
What do you mean at least one test? I shoot for
We're
a
not
test on
having 2
Friday.
tests on Friday. That's reminding me of the summer course. It's going to make me scared.